Hello and welcome to this section of the Physics 3 tutor. In this section we're going to expand our knowledge a little bit and begin to talk about what happens if you have a wire carrying an electric current and you place that wire into a magnetic field. What's going to happen? And I'll tell you the punchline if you think about it. We already know that if we have a magnetic field and we shoot particles or some kind of charged particles, electrons or something, into the field, the force that's exerted is going to be force is equal to Q times V cross B. It's a cross product. It's going to curve that electron in a sort of an arc, and if there's a field there that's uniform, it'll just orbit around and around and around. Now think about, what is a wire carrying electricity? A wire is billions of electrons flowing through the wire, so lots and lots of moving particles. So it would make sense that if we take a wire and place it into a magnetic field and then turn the current on in that wire, it would make sense that the magnetic field would exert a force on all of the little charged particles moving in that wire, and thus the force would be exerted on the wire itself. And that's exactly what happens. If you take a magnetic field and you've got it on, and then you place a wire in it, it's hooked up to a circuit, and you turn the electricity on in that wire, the wire will physically begin to move. It'll be pushed by the magnetic field. And so that's what we're going to learn about here. What does that force look like and all of that? So what I'm going to do here is, I think what I'm going to do is give you the punchline first. I'm going to draw a quick diagram and show you what the force and what the equation is that describes the force on a charge, I should say a force on a current carrying wire, which is really what the title of the section is. And so you'll have it, right, and sort of in the forefront of your brain. And then I'm going to break with tradition a little bit and I'm going to derive it for you. Sometimes in physics I think it's better just to present the formula and tell you to use it, because sometimes doing all the derivations for everything just kind of like derails us a little bit too much. But in this case, since we already have discussed in the last section exactly why the force arises on a particle, then it really becomes nice to do this derivation, because it follows directly from it and it gives you practice in doing that logical thinking and logical derivations that you see all the time in your physics books. And let's face it, a lot of us, when we read those derivations in those physics books for the first time, you may not get it, you may get lost. How did they do that? So I'd like to kind of present that for you. But before you actually derive anything, I want to give you the punchline, because that way you'll know where we're going. So if we have, let me draw a quick magnetic field on the board. This is our magnetic field. It's coming toward you out of the board. I'm trying to draw these little dots as fast as I can. So here's a bunch of dots. It's uniform. It goes on and on everywhere, but I'm just drawing a little bit of it here. All right, now this magnetic field is coming from me to you. Now inside of this guy is a segment of a wire.